Welcome dear friends, dear all friends. Today we will discuss calculus differential, calculus part differentiation. Okay. I think this class is a third class. Now proceed from question number 19. Okay. This is differentiation, calculus sub part is differentiation. तो आज हम लोग चलेंगे आगे की ओर. So question number 19 say that find dy by dx for y equal to tan inverse root over 1 minus x upon a plus x and x lying between minus a to a open interval. ओके. तो इससे पहले हम आप लोग को एक सूचना दे रहे हैं कि जो भी हम क्लास करवाते हैं उसको शुरू से देखने से, कोई भी टॉपिक स्टार्ट होता है उसका स्टार्टिंग वाला टॉपिक से देखने से बेनिफिट मिलेगा. ठीक है. आप लोग लाइक सब्सक्राइब वगैरह किया कीजिए, चैनल को शेयर कीजिए, ताकि इससे क्या होता है कि मनोबल बढ़ता है, इंकरेज होगा हमारा मनोबल. तो उससे ज़्यादा से ज़्यादा क्या होगा कि मेहनत होगा, मेहनत करेंगे इसमें कंटेंट अच्छा से अच्छा कंटेंट और अच्छा से अच्छा डिस्क्राइब करने के लिए. ओके. सो नाउ लेट्स गो क्वेश्चन नंबर 19. गिवन y क्वेश्चन नंबर 3.19, that means question number 19, given y equal to tan inverse root over a minus x upon a plus x. Here is a for finding dy by dx. Firstly we simplify this term by putting x equal to, this is like a 1 minus cos theta and this in the below 1 plus cos theta, and this will gives 2 in minus 2 sin square theta by 2, and this will give 2 cos in positive formula will be cos square theta by 2. Okay. So now we put here a is value 1, so we take a cos theta. Okay. And this will get value of x, value of theta is cos inverse x upon a. Okay. This will the theta value, and now we put here y equal to, when put x, value of x, tan inverse root over a minus a cos theta upon a plus a cos theta. Okay, all are clear? And this will give tan inverse a, this formula a common here, and left 1 minus cos theta, and cos theta, this gives a 2 sin square theta upon 2. Okay. So here we put 2a cos theta, a 2 sin square theta upon 2, and theta is x, sorry, yes, okay, theta, and in the below a into 2 into cos square theta upon 2, and this 2 and this 2 ye cancel out. Okay. So here sin square theta and cos square theta is this gives sin theta upon cos theta is tan square theta upon 2, and root over a square cancel out. This gives y equal to tan inverse tan theta upon 2. Tan inverse tan theta will be common out, then this gives theta upon 2, and value of the theta is cos inverse, this gives y equal to 1 upon 2. This 1 upon 2 is out and put the value of theta is here. Cos inverse x upon a. X upon a. Now we differentiate this function. This simplify functions. We get y. Now differentiate. On differentiation or differentiation with respect to function in x. So with respect to x we get dy by dx equal to, and 1 by 2 is our constant, so constant is out, and differentiation of cos inverse x differentiation minus 1 upon root over 1 minus x square, and x is in the place of x is x upon a, x square, and by the chain rule we differentiate x upon a is a multiple composite functions, so differentiate 1 upon a, x by a, because x by a differentiation of this 1 upon a is a common out, and differentiation of x is a 1, so this gives 1 upon a. Okay, clear? Next, so therefore this implies dy by dx equal to 1 upon minus 1 upon 2a, and this is a square minus x square upon a square. Root here separate, and 1 upon 2a square minus x square, and this root in below, above and below, this is a common out from the root. This will gives a value of a square, root over a square value gives a, and this a and this a cancel out, so dy by dx equal to minus 1 upon 2 root a square minus x square. This is our final answer. Please like if you understand. If you don't understand, then you ask which step you not understand. Okay, अगर आपको समझ में नहीं आता है जिस स्टेप पे, उसको वहां पे पूछना है. अगर समझ में आ रहा है तो लाइक करना है. ठीक है, now we proceed. Next question number 20. Question number 20 asked question number 20 say if y equal to sin inverse x root 1 minus x minus root root 1 minus x square, and x lying between open interval. This is not equal, so not we say close interval. Okay, not we consider close. If less than but not equal, then we say open interval. Okay, then find the value of dy by dx. So in question 20 3.20, question number 20, y given the value of y sin inverse x root 1 minus x minus root x root over 1 minus x square. Okay, here we see that use the formula of sin inverse a minus sin inverse b. Okay, sin inverse a minus sin inverse b. We know that value of sin inverse a minus sin inverse b. We know formula of sin inverse a minus 1 minus b square for cos minus this value b root over 1 minus a square. Okay, and this gives, so we change this formula in the form of sin inverse a minus sin inverse b, in the sin inverse a minus sin inverse b. So firstly we here see that a square of value, but here is not a square, so we change this x in a square. So firstly we y transform in sine inverse x root over 1 minus x. We can write a square of root x. We can write x in the form of root x square. Okay, this will give this also. We can derive in root x into x, root x, and this root x and root x is a x square, so can common out only x, so these values are equal. So we write x in the form of root x square. Okay, you can understand. So here we write in the place of x root x square minus root x root over 1 minus x square. Now we compare from this formula. Okay, sine inverse a, value of a is x, and 1 minus b square, value of the b in the place of b is root. Okay, root x, all are same. So therefore so y equal to sine inverse x minus sine inverse root over x. This is the value of y. Now we differentiate. This is sine inverse x and minus sine. Now differentiate. Now we differentiate. On differentiation, on differentiation, we see dy by dx, differentiation of sine inverse x, 1 upon root over 1 minus x square, minus, here is a minus, so we write minus, and differentiation of sine root x 1 upon 1 minus x square, this x square, 1 minus root x square, because in the place of x is root x, so this calculate 1 upon root over 1 minus x square minus 1 upon 1 minus x. Okay, this is our final answer. You can also solve this in the next more in a step, or you leave. Sorry, here is a composite function is also applied, so we apply chain rule. In the place of x is root x, so root x differentiation also here we do root x differentiation here. So root x, differentiation of root x to root x. So this is our final answer. Now 1 upon 1 minus x square minus 1 upon 2 root x, 1 upon 2 root x, root x is right this form, and this is minus, this square is 1 minus x, sorry, a square root is out, a square is a cancel, sorry, a square root is cancel, then we only left here x. Okay, so and this x is under in root x. Okay, we take in root under root. Okay, because if you not understand, if a into root b, we can write a into b, multiply this under root, we take in the multiply. Okay, so this root and this root multiplying x in this function, and this is 1 minus root x square, and this root x square a squaring, so this root is cancel out, so 1 minus x is here left. Next, this is our final answer. Okay, now we proceed question number 21. Okay, this here apply a special type of a pattern, in a question number 21. Question number 21 say, if y equal to tan inverse 1 upon x square plus x plus 1 plus tan inverse 1 upon x square plus 3x plus 3. Okay, and next tan inverse 1 upon x square 5x plus 5x plus 7 plus dot 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 up to n term. This series you can write up to n terms. Then find the value of question say ask. Then find the value of y dash 0. That means differentiation. Firstly we differentiate this function and put the value of x in the place of x. We put x equal to 0. Okay, firstly we solve dy by dx. That means y dash. In question number 21, given y equal to tan inverse 1 upon x square plus x plus 1 plus second term tan inverse 1 upon x square plus 3x plus 3 and so on up to n terms. Okay, so this will be deriving tan inverse x. We can write in the place of 1 x plus 2 minus x plus 1 minus 1. How you understand why you write x plus 1 minus 1? Okay, so you can factorize x plus 1 in the form of tan inverse a minus tan inverse b. We know tan inverse a minus tan inverse b. Simply write tan inverse a minus b upon 1 plus a into b. Okay, a into b. So we change this in the form of 1 plus a into b. Okay, a into b. Here write 1. So we change in this form. Here write 1 plus this and x. From this and this x we can common x 1 plus x. We can common x plus 1. So here we left x plus 1. Okay, now here value of a is a x and value of b is a x plus 1. So we write in the place value of a is a x plus 1 and minus x. Sorry, this will be right here. वैल्यू ऑफ ये यहाँ है, वैल्यू ऑफ ये बी वहाँ पे है. मुझे चेंज करना था टेन इनवर्स अभी जो फॉर्मूला लिखे थे उस फॉर्म में, तो इसीलिए मैं क्या किया हूँ उसको चेंज कर रहा हूँ. ठीक है, तो पहले जो पॉजिटिव देगा ऊपर पॉजिटिव आ रहा है, इसलिए मैंने क्या किया पहले इसको लिखा. तो ये वैल्यू ऑफ ये हो जाएगा, मतलब वैल्यू ऑफ ये एंड वैल्यू ऑफ बी इज दिस टर्म. ओके, सो वैल्यू ऑफ ये. now you can understand why we write this in this form, because changing in tan inverse a minus tan inverse b. This will hint the here in this term. So 1 plus, here we write x into x plus 1. Similarly in the next term tan inverse this will write x plus 2 minus x plus 1 and upon 1 plus x plus 2 and x plus 1. Similarly in your next term we can write tan inverse x plus 3 increasing in the order x plus 1 x plus 2 x plus 3 minus x plus 1 x plus 2 upon 1 plus x plus 3 into x plus 2. When you solve or you derive this term, then you can get this x square plus 5x plus 7, x square plus 5x plus 7 in this next term. Okay, plus dot 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 up to n terms. We solve in the easiest step. Next, in the next step we get tan inverse x plus 1. Here and minus tan inverse b, tan inverse x. In next term, tan inverse x plus 2 and minus, here is a minus, so minus we write tan inverse x plus 1 and so on. And last term is our we write tan inverse, firstly we write highest term, so tan inverse n x, x plus n, x plus n minus, in the next term tan inverse x plus n minus 1 term. This is up to n term. Now we see that here tan inverse x plus 1, tan inverse x plus 1, tan x plus 2 and tan x plus 2 cancel from here, and tan x plus 3 and tan x plus 3 in the next term, so cancel in the next term. So this term is cancelled out from here. Now we see minus tan inverse x is left and this term is a left, only this term and this term only left, tan inverse x plus n. Now we can easily differentiate this term, so y dash on differentiation with respect to x, so we get y dash, you can write this function in a yx, so you can write y dash of x, or this will be write y of x because function in x variable, so we write y dash on differentiate is a dash representation is a differentiation, and tan inverse x minus and tan inverse x differentiation root of 1 plus x square. Next term in differentiation of this will give 1 plus x square, in the place of x plus n square, square of x plus n. Okay, in the place of x here n. Now we put value of x is 0, so we get 1 upon 1 plus 0 square plus 1 upon 1 plus 0 plus square of 0 plus n square of 0 plus n. This gives minus 1 and this gives 1 upon, here is plus 1 plus n square. Now we solve y dash 0, we can write here minus 1 plus minus n square plus 1 and upon 1 plus n square. This gives this one and this one is a cancel, so minus n square upon 1 plus n square is our final answer. Okay, and if you feel any step doubt, then you can comment the step where you doubt feel, then I solve, clear your doubt in the comment section also do. Next we proceed 3.22, that means 22 question number. In the question number 22 say question number 22 say let f r to r, that means of functions f r to r be a 1 functions, r to r be a 1 function, 1 and on 2 functions. That means when function is a 1 and 1 2, if only 1 then this function is a invertible, that means this functions exist inverse function. If 1 is given, 1 and 1 2 differentiable functions such that f of 2 equal to 1 and f dash 2 equal to 3, then find the value of dy dx f dash x at the point x equal to 1. Now we see here, see very easiest step, we see in the very easiest step how we solve. Firstly rub the board then discuss question number 22. Here firstly we consider f function because not given, but here is a hint, find f dash f inverse f of x, f inverse x, find definition of f inverse x. Okay, सो इन्वर्स फंक्शंस का मुझे निकालना है डिफरेंशिएशन, तो मैं इन्वर्स फंक्शन को ही मान लेता हूँ कि कुछ फंक्शन तो होगा तभी तो उसका निकलेगा। सो क्वेश्चन नंबर 3.22 क्वेश्चन नंबर 22, let f inverse x equal to one new functions, one new functions. This will give first g of x. F inverse x is a given, we assumed a g of x. Okay, so we can write x, this inverse change in this side, so this will give f of g of x. Okay, that means f of g of x equal to x in the second step. Now we can differentiate this equation to this functions, second functions, differentiating on both side, differentiating on both side, differentiating equation 2 on both side with respect to x, we get f dash, but differentiating these functions by chain rule because this is the composition functions. So g of x and differentiation, firstly differentiate f dash fx, then differentiate gx, so this gives g dash x, and right side differentiation of x is 1. Now here we see, we find g dash these functions from right side because here is a multiply. So firstly we write g dash x, because when we differentiate these functions, then it gives differentiation of inverse of f of x. So we can write f dash g of x, because f dash g of x is a multiple in g dash x with g dash x functions. So we write g of x in this. Now we put value of x is 1. Sorry, 2. Value of x is 2 or 1? 1. If anything is given, finding the value of something left in the questions or not? Question given, no. All right. G of x, f of 2 here, right? Now we can find if this is 3, differentiate 1 on differentiating 1, differentiation of d of x, f inverse x, and this gives g dash x. Now we put value of 1. At x equal to 1, we see dy dx f inverse 1, this gives g dash 1, and this is 4. Now from 3, if we put here is the value of 1, when we differentiate, so value of 1 something, a calculation wrong or right, कुछ तो गलत कर रहे हैं, ये सही है, देखा जाए. After this step, we confuse in this step, g of x is the inverse of f. Okay, so when we put value of g of 1, f of f inverse x is g of x, this will give from the given value f of 2 equal to 1. Okay, so inverse of f of 1, this gives 2. Okay, inverse of f of 1 is gives 1. So this inverse f of 1, we put value of x is 1, then this will get f inverse of f is f inverse 1 and equal to g of 1, and f inverse 1 is will give 2, that means g of 1, value of g of 1. So from in this equation 2, in the equation 2 we get g dash value 1 and 1 upon f dash g of 1 in the place of x, and value of g of 1 is 2, so here we put 1 upon f of 2, value of g of 1 is 2. Okay, so and f dash 2 given, f dash 2 given value is 3, f dash 2 given value is 3, so our final answer is 1 upon 3. Okay, next question number 23. Proceeding before question number 23, we discuss product rule and quotient rule, because in this question apply quotient rule, and in this question number 24 apply product rule. Okay, first clear up the board and then we discuss cost product rule and quotient rule. Product rule, firstly we discuss product rule. Firstly we discuss product rule. Okay, in a product rule, given function in the form of f of x, or we can assume y given in the two product function or more product functions, then differentiate in the form of, in a two conditions, y given in a multiple of f of x or y equal to multiple of many functions f of x, g of x, h of x, and so on. Firstly we see multiplying two functions on differentiating multiplying functions, that means product functions, how we apply differentiation of multiplying function on multiplying functions. So differentiating y with respect to x dy by dx, this will give, firstly differentiate any one functions, we differentiate f dash x, then g dash x left out, then plus, and now it left first function differentiate, then in the second step which function left, firstly differentiate functions is left in the second step, and left in the first step function is differentiate in the next step. So this is our product rule. And for many functions differentiating many functions in the product form, then how we can differentiate the product of the functions of many functions. So differentiating of this on this side, we get how we can differentiating dy by dx, similar as this step, in, or you say this is the in general form, in generalized form. Okay, generalized form, differentiate f of x, left remaining functions gx, h of x, and so on. In the next step, differentiate second functions g dash x, and remaining function is fx, hx, dot, and so on. In the third step, differentiate third function h dash x, and remaining function is f of x. When third function differentiate, the first function remaining, second function remaining, and fourth functions remaining, and so on, and this is proceed on similar way. ओके, मतलब जब dy by dx मेनी फंक्शंस का हो तो पहला फंक्शन जब डिफरेंशिएट करते हैं तो बाकी सब बच जाता है, दूसरा फंक्शन डिफरेंशिएट करते हैं तो पहला और बाकी सब बचेंगे, तीसरा जब डिफरेंशिएट करेंगे और सब में प्लस होगा मल्टीप्लाई में, तो तीसरा डिफरेंशिएट करेंगे तो फर्स्ट सेकेंड और रिमेनिंग फंक्शन थर्ड के बाद 4 5 6 7 इससे सारे फंक्शन बचते रहेंगे। ये हमारा जनरल फॉर्म है। अब हम लोग देखते हैं क्वेश्चन रूल का। अच्छा, ये प्रोडक्ट रूल हम लोग इसको देख लेते हैं। प्रोडक्ट रूल का आपका यहाँ पे दो क्वेश्चन है, क्वेश्चन नंबर 23 एंड 25। तो फर्स्टली वी डिस्कस क्वेश्चन नंबर 23 and 25. Question number 23, given f of x. Question number 23, 3.23, given f of x equal to cos x cos 2x into cos 4x into cos 8x into cos 16x cos 16x. Here we apply cos 2 sin theta into cos theta formula. Okay, so we apply, this will give 2 sin theta, sin 2 theta, sin 2 theta. So in change in this form 2 sin theta cos theta. So here absent 2 sin theta, so we are multiplying by 2 sin theta and dividing by 2 sin theta. In this step 2 sin theta and cos theta cos 2x, sorry, x in theta in the place of x, that means in the place of theta is x, into cos 4x into cos 8x into cos 16x, dividing 2 sin theta, 2 sin x, sorry, in the place of theta is x. This multiplying in how many times? 5 times for one, this and this, how many times? 5 times. So this will give sin 2 theta, sin 2x, sin 2x and cos 2x. This will are left. Formula of 2 sin theta cos theta, 2 sin theta cos theta, 2 sin theta cos theta is a sin 2 theta. Okay, 2x cos 4x cos 8x and cos 16x. We see, we apply here only left 2, we require only 2 here only, so 2 multiply and divide sin x. So how many times to multiply? एक बार के लिए एक बार कर चुके हैं तो 5 टाइम्स है, तो 5 टाइम्स के लिए क्या होगा? 5 टाइम्स मल्टीप्लाई करेंगे, ठीक है। उसी तरह से एक बार हम दिखा दे रहे हैं यहाँ पे, ये इतना आएगा तो 2 मल्टीप्लाई किए अपने से, टू भी डिवाइड करना होगा। व्हेन 2 मल्टीप्लाई इन द न्यूमरेटर देन 2 डिवाइड्स, 2 आल्सो मल्टीप्लाई इन द न्यूमरेटर डिनोमिनेटर। सो ये कितना बार हम लोग का मल्टीप्लाई होगा? 5 टाइम्स। नीचे जो आएगा मेरा वो 5 टाइम्स मल्टीप्लाई होगा, दैट मीन्स 2 to the power 5 आएगा एंड sin x. Okay, so this gives 2x for only x, for this x. So similarly for in the 16 theta in the 16x, तो 16x के लिए हमारा कितना दूर तक चल जाएगा? sin 16 into 2 32 तक जाएगा कि नहीं जाएगा? तो 32x, so this gives 32x. Now we differentiate this y in the quotient form. This is a quotient form. Okay, sorry, that means product of form is 24 number questions. Also discuss firstly product form, sorry, quotient form y given in u of x or f of x upon g of x. This is a quotient, this is a quotient rule for differentiation, quotient rule for differentiation, डिफरेंशिएशन क्वेश्चन के लिए क्या होता है, ऐसा है एफ ऑफ एक्स वाई मतलब डिवाइडिंग में रहता है, सो एफ ऑफ एक्स अपॉन जी ऑफ एक्स एंड जी ऑफ एक्स नॉट इक्वल टू जीरो बिकॉज व्हेन जी ऑफ एक्स इज इक्वल टू जीरो देन दिस वाई इज नॉट डिफाइंड. ओके, सो डिफरेंशिएटिंग dy by dx with respect to x. So firstly differentiate this denominator functions common out and differentiate above numerator functions and minus now we differentiate denominator functions and left out numerator functions and the square of denominator functions. This is our quotient rule formula. Okay, this is our quotient rule formula. So here we apply quotient rule formula on differentiating with respect to x. This gives dy by dx equal to, firstly differentiate 1 upon 2 to the power 5 is a constant, so constant is common out. Then we apply quotient rule. So sin x is a denominator function, so sin x is a common out, and differentiating of these functions is cos 32x, and 32x differentiation by the chain rule, so 32, and minus now left the numerator function 32x, numerator function left, and differentiating of denominator function is sin x, so this gives cos x, and a square of sin x. Okay, this is our, now we try to solve this calculations in 23 number questions. Solve in the way in the 20, then find the value of f dash pi by 4. This is a f of x, so this is f of x, so this differentiating, when differentiate then this gives f dash x. So f dash x is the value of this. Now we put the value in the questions asked, value of f dash pi by 4, so we put the in the place of x is a pi by 4, so sin pi by 4 into cos 32 into pi by 4 into 32 in outside, minus sin 32 into pi by 4 into cos pi by 4, in the below, in the denominator sin pi by 4, the square of sin pi by 4. Okay, this gives 1 by 2 to the power is a 32, 1 by 32 to the power 32, and this sin pi by 4 is a 1 by root 2, and this is 4 8 times 32, that means this multiply cos 8 pi multiple of 2, so multiple of 2 is a value gives 1, this gives value 1 minus, and sorry 32, this 32 is here available, and minus, now we write minus for 8 pi multiple of n pi is a 0, sin n pi is a 0, and cos pi by 4 is a 1 by root 2. Here sin n pi is 0. Okay, so this gives 1 by 32, and this 1 by 32 and this 1 by 32 is a cancel out because this term is a 0, so this is a cancel out, and this remaining is a remaining term now, and dividing in the denominator 1 upon root 2 square of 1 by root 2, 1 upon root 2, so here we left So here we left 1 by root 2 in the above and denominator root 2 upon 1 square. So squaring is a common, then this gives 1 2 upon 1. If you not understand, then you can write root 2 upon 1 square. 1 square is cancelled from this 1 upon root 2. Okay, this root 2 is cancelled out from this 2. So only left root 2 answer. This is our final answer. Now we proceed. Question number 24. In question number 24, say, oh sorry. In question number 24, if cos y equal to x cos a plus y with cos a value is plus minus 1, value of the cos a plus minus 1, then we prove that dy by dx equal to cos square a plus x upon sin a. Okay, sin a. Question number 24, 3.24. Question number 24. This say, this is a given condition cos y equal to x cos e plus y. This is our given condition. In question number 25, given condition cos y equal to x cos a plus y, then prove that dy by dx equal to cos square, then okay, cos square a plus x upon sin a. So here we find x, this is gives in this side, then we get cos, this side is the multiple of this term. In this side, when we change cos a plus y in left side, so in the dividing in the cos y, so a plus y, this gives a plus y. Now we can differentiate this with respect to x. This function in the form of in the variable y. So differentiating with respect to y, because variable is a y, with respect to y we get dx by dy, and differentiation this apply by coefficient rule, dy by dx apply coefficient rule. So when coefficient rule, sorry, there is not a square, only cos a plus y, applying coefficient rule, then denominator function is common out and differentiating numerator functions and differentiation of numerator functions cos y. So cos y differentiation minus sin y and minus in the middle. Now differentiate left out numerator functions and differentiate denominator functions in a cos. So this gives sin a plus y, and differentiation of a plus y is 0 plus 1. Okay, and dividing by square of cos a square a plus y, denominator functions, square of denominator functions, by the differentiating of by constant rule. So this gives minus sin y cos a plus y, minus this minus plus gives plus, and cos y sin a plus y, this is plus, here applying sin a plus sin b, a plus y, here applying in the numerator sin a minus b formula of sin a minus b. So sin a plus y minus b divided by cos square a plus y. How we get this done? Because sin a minus b equal to sin a cos b minus sin b, or you can write yes, sin b cos a. Comparing this formula, firstly plus cos cos b sin a in the place of a plus y. Okay, so a plus y, a minus b, so in the place of a is a plus y minus b minus sin b cos a minus sin b minus sin b cos a. So we write a minus b in the place of a, in the place of b is y. Okay, now we solve or derive. This y and this y they cancel, so only a left, and here in the denominator cos square a plus y. Now we can change dx upon dy. In the proving questions ask dy by dx, so we interchange dy above and below, then this will also interchange cos square a plus y and upon sin a. This is our final result. Okay, this is our final result. कहीं कोई दिक्कत तो नहीं होना चाहिए. नेक्स्ट वी सी क्वेश्चन नंबर 25. Question number 25. Find dy by dx y equal to when y equal to x sin x log x. That means this, here we apply product rule. Question number 25. Given y equal to x sin x log x, x into sin x into log x. In question number 25, y equal to x sin x log x. On differentiating by product rule, with respect to x, dy by dx. First function, so differentiation of x is 1 and left out remaining functions sin x and log x. In the second step, second term, differentiate second functions, so remaining function is x and differentiation of sin x is a cos x into remaining functions also log x. In third step, differentiate in the third functions, so remaining function sin x first function and second function sin x, and differentiation of log x is 1 upon x. This x and this x is a cancel, so here left sin x into log x plus x cos x log x, and remaining last term is a sin x. This is our final result. Okay, now we proceed. This question is a very simplest form. And now next to question number 26. And 26 we apply differentiability functions, limiting value. In the limiting classes we also discussed differentiability, how to differentiability functions. That means how we can differentiate functions. We solve for limiting functions. Limit h tends to 0 f of a plus h minus f of a upon h. This gives differentiation of, so this limiting value is also, here we use limiting concept. This limiting concept here we discuss in a limiting classes. Okay, limit class lecturer. So question number 3.26. 26. Given limit h tends to 0, evaluate f does a. Limit a plus h square sin inverse a plus h minus a squared sin inverse a dividing by h. Here now we just see f dash c equal to limit h tends to 0 f of c plus h minus f of c divided by h. So we apply this formula is here. We get f dash and the value of c is a. That means f dash a. So f dash a in the f dash a is a differentiation of f dash. So f dash differentiation dash means differentiation of a square with respect to, because variable in a, so we differentiate these functions in variable a sin inverse a. Now we differentiate these functions. This is a product rule, a square into sin inverse a. Firstly we differentiate first functions, so differentiation of a square is 2a and left out sin inverse a plus in the second term first function is left out and differentiation second functions. So differentiation of sin inverse a 1 upon 1 minus a square. Okay, this is our final answer. 2a sin inverse a square root over 1 minus a square is our final answer. Okay, any problem in these questions? If you feel problem in any step, then you ask in comment sections. I clarify in your doubt in the comment section. Okay, 25 and 26. Next question 27 number, differentiating by quotient rule. So much easiest question. In question number, हाँ बैठो 4 बजे ही कहे नहीं आते हैं जी? 4 बजे आना चाहिए ना। चलो बैठो तब आ गया है, तभी क्या बोल गए नहीं 4 बजे आएगा। 4 बजे आएगा, जाओ बाबू भी आएगा 4 बजे। हाँ तभी कहाँ है तो ठीक है। आज कहाँ छुट्टी? 5:15 में मिलेगा। Question number 27. Question number 27. Y equal to e to the power x 1 plus sin x 1 plus sin x. This is a very easy in the easiest form, easy functions. So differentiate in easily form. On differentiating y dash, on differentiating with respect to x, this gives y dash. Differentiate. Firstly, we common out denominator functions and differentiate numerator functions. Differentiation of exponential is also exponential is the same function. That means differentiation of ex is also ex. Okay, so we write ex minus, now e exponential is common and differentiating a denominator functions 1 differentiation of 1 is d0 and differentiation of sin x is a cos x. That means ex cos x and 1 plus sin x square whole square of 1 plus sin x. Okay, now ex we common, exponential is common, the 1 plus sin x minus cos x upon 1 plus sin x square of 1 plus sin x square. This is our final answer. And the next question number 28, क्वेश्चन नंबर 28 और 29 दोनों सेम था इसको, क्योंकि क्वोशिएंट रूल इसके बाद दिया था, प्रोडक्ट रूल दिया था, इसलिए प्रोडक्ट रूल आपको एक बार यहाँ पे दे दिया और यहाँ पे क्वोशिएंट रूल इसमें अप्लाई हो रहा था, यहाँ पे दे दिया था, ठीक है, इसलिए ये क्वेश्चन रिपीट कर गया था। क्वेश्चन नंबर हम लोग 30 देखते हैं कैसे बनाना है, ठीक है। क्वेश्चन नंबर 30 अभी हम लोग बना लेते हैं, 1 मिनट। क्वेश्चन नंबर 30, we apply here quotient rule also. प्रूफिंग करने बोला है, चलो चलते हैं क्वेश्चन नंबर 30 में, आज खत्म ही कर देना है इसको। क्वेश्चन नंबर 30 में दिया हुआ है, 30 जो है मेरा वो क्या दिया हुआ है, y इक्वल टू रूट ओवर 1 माइनस एक्स 1 प्लस एक्स, ये है, ठीक है। तो ये है, इसमें प्रूफ करने बोला है 1 माइनस एक्स स्क्वायर इंटू डी वाई बाई डी एक्स प्लस वाई इक्वल टू 0। देन प्रूफ दैट 1 माइनस एक्स स्क्वायर इंटू डी वाई बाई डी एक्स प्लस वाई इक्वल टू 0, ओके। y इक्वल टू रूट ओवर 1 माइनस एक्स अपॉन 1 प्लस एक्स, तो प्रूफ करना है। देन प्रूफ दैट 1 माइनस एक्स स्क्वायर डिवाइड बाई डी एक्स प्लस वाई इक्वल टू 0, ये मुझे प्रूफ करना है, ओके। नाउ वी प्रोसीड फ्रॉम y गिवन कंडीशन ऑन differentiating this gives dy by dx, this gives dy by dx, and this is these functions we can write 1 minus x upon root over 1 plus x also. So firstly we differentiate numerator functions and common out denominator functions. So differentiate of 1 upon root x. Question is 1 minus x. Yes, 1 minus x. That means we are true. So differentiation 1 minus root x is 1 upon 2 root 1 minus x, and differentiation of 1 minus x is a minus 1. So we take here minus 1, okay. Now minus, now differentiate our denominator function and common out numerator functions. Here differentiation of 1 upon 2 root x, 2 root x, and differentiation of 1 plus x is a 1 plus 0 plus 1. So this is a 0 plus 1 gives 1 value, gives 1. Now we calculate in the below 1 plus x, the square of root over 1 plus x in denominator functions. Now we only simply calculate this function 1 plus x root over 2 1 minus x, and here is a minus 1, and here minus this 1 minus x upon 2 root 1 plus x. When we differentiate, and this gives this dividing functions 1 plus x, because here is a square, then a square root is a cancel out. Why this will give no. Here different types of, अब यहाँ पे हम लोग क्या कर सकते हैं, इसको कॉमन आउट 1 by root 2, 1 by 2 common out 1 by 2, and similar as 1 minus x upon 1 plus x we common out from both terms. Here is not present 1 minus x in the above. So when common 1 minus x in from above, so in the below, the above we left double term. Firstly we write minus and 1 plus x upon 1 minus x, and similarly here now 1 minus x, so only left 1 and 1 upon 1 plus x, 1 plus 1 upon x. This is our common out. This term is a common out in this equation, so we get here different types common in a questions. 1 plus x common. Sorry, this term is a common out from this and this term. This term is a common out. 1 by 2 is here and minus is also in both term. So when we common root 1 plus x and root 1 minus x, then we here left only 1 plus minus common, then sign all terms sign change hai. Here this common from below sides, so here in a double and here is also double. This common term 1 minus x and 1 plus x, because when we root with root common, so this root when we common, so this is also divided in above side. Okay, so this root is cancel out in the both term above and below, and then next 1 plus x is left out. Now we calculate 1 upon and this is 1 upon 2, 1 plus x upon 1 minus x. This is 1 plus x minus, sorry, plus 1 minus x, 1 plus x, and this 1 plus x and this 1 plus x is a square. This x and this x is a cancel out, and next term here is a 2 minus 1 by 2, and here left 1 plus x upon 1 plus left 1 minus x. And plus x, and here is a left 2 upon 1 plus x squared. Now this 2 and this 2 cancel, and here is a minus, so we write minus. This implies dy by dx equal to minus root over 1 plus x upon 1 minus x into 1 upon 1 plus x square. In the next step we multiply both sides 1 minus x square. In the next step we multiply in both sides 1 minus x square, 1 minus x square in both sides, so we get here dy by dx, and in this step 1 minus root over 1 plus x and 1 minus x, here we get multiply by 1 minus x square, and 1 minus x square we can transform in the other form. 1 minus x square is transformed in a square minus b square, so 1 plus x into 1 minus x. So here we write 1 plus x and 1 minus x. So 1 plus x is cancelled from 2, power 2 is left only one term, and next we see here 1 minus x square dy by dx is left in this step, and minus is here root over 1 plus x upon 1 minus x root here, but here is a not root, here left is in this term 1 minus x and 1 plus x. When we take a square root of 1 minus x, 1 plus x, this will give same value of this. So we can also take here a square root of this, when we get a square root. This term is out when, we can write this in 1 minus x square types, and this also we write 1 plus x square. Okay, so here we write 1 minus x square and below 1 plus x square. This is the same root. So here one term is a cancel out. We can also write here a square root term, yeah, this type, or we can also write this type, a square root of 1 minus x. Yes, we can also write 1 minus x upon 1 plus x in the easiest form, a square form. So we divide, transform in both in the square. So we write in this form. So not we take in here a square, we take outside a square for cancellation in the easiest form. This term is a divide root, separate in the root. This one terms and one terms, this one and this one is cancel out. So here only one left. So here only one left with minus here, and root over 1 minus x upon 1 plus x, and this is the value of y. This is the value of y. So we write minus y. Therefore minus y is we can write in the left side dy by dx, and this minus y, when we come left side, then we write in the plus form. So hence our result proved. दिस इज आवर फाइनल रिजल्ट. ओके, सो इतना इजी वे में इसको सॉल्व किए हैं, सब जगह तो बता ही दिए हैं, कोई ऐसा हार्ड नहीं है. एक क्वेश्चन नंबर 31 बच रहा है, उसको भी देख लेते हैं. यहाँ पे कोई कुछ वैसा नहीं होना चाहिए, ठीक है, सब कैलकुलेशन किए हैं. बुक में कुछ अलग तरह बनाया है, बुक में दूसरा जैसे बनाए हैं, हम दूसरा जैसे बना दिए हैं, ठीक है. Now we proceed. Question number 31. Find the sum of the series 1 plus 2x plus 3x square plus 3x square plus n minus 1 and x square. So firstly we know in this questions use finding differentiation. Find the sum of the series. इस सीरीज का फाइंड करना है सम आपको, ठीक है. यूज क्या करते हुए, डिफरेंशिएशन का यूज करते हुए. इन क्वेश्चन नंबर 31 गिवन y इक्वल टू, सपोज फाइंड द सम ऑफ 1 प्लस 2x प्लस 3x स्क्वायर प्लस डॉट 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 प्लस n minus 1 x to the power n minus 2 equal to what is the value. This question is asked the value of this sum of the series. So we know that we know that 1 plus x square plus x cube plus dot 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 plus x to the power n is 1 minus x to the power n upon 1 minus x. X. This is our result. We know 1 minus x to the power n and 1 minus x. This is our result. We know. Now we can differentiate in both side. Differentiating both side with respect to x. with respect to x, we get differentiation of 1 is 0 and differentiation of x is 1 and differentiation of x square is 2x, 3x square plus dot 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 n into x to the power n minus 1, and this side applying quotient rule. 1 minus x is common out and differentiation of this is 0 minus n into x to the power n minus 1. So here is only left 0. 0 minus in the midterm. Now we come left out numerator functions and differentiation of denominator is minus 1 and differentiation of 1 is constant is 0. That means here is only minus 1 left, and in dividing 1 minus square whole square of 1 minus x. Now we see 1 plus 2x plus 3x square. Here 3x square plus dot 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 plus n into x to the power n minus 1, and in the right side this is multiplying in this term multiplying with 1. This gives same as x to the power n minus 1 with multiplying x with, when x multiply then power is just added, okay, because x into x to the power n minus 1, so power is here 1. So in the multiplying power, all power of x in adding form, okay, this is a plus 1, so you can also write here plus 1. This is value 1 plus n minus 1, this minus 1, this minus 1 cancel, plus 1 minus 1. So here left only x to the power n, so here only left x to the power n, x to the power n, and n is also available, n is also available constant, and this in this term minus minus plus and bracket out minus x to the power n upon a square of 1 minus x square, okay. Now we can write this x to the power n, this x to the power n is common, so here 1 minus n x to the power n minus 1 and x to the power n and x to the power minus 1 is common here. Then here is left 1 minus x to the power n, because here left 1 and minus common, so in the both places plus 1, and here 1 minus square of 1 minus x square. This is our result, okay, this is our final result. ये हो गया. कल हम लोग एक्सरसाइज स्टार्ट करेंगे 3.2 का. सो आप लोग लाइक और सब्सक्राइब जरूर किया कीजिए और शेयर भी कीजिए अपने दोस्तों में, ठीक है.